Wonderful. Okay. So, thank you. I think that you should be able to play with and inspect and debug and change a running distributed software system all from within your plain old text editor. So what I built is a simple ClojureScript environment where you can see the value of any expression. You just hit a shortcut and it wraps it in what I call a query macro. When you change the code and save, the value will update. If you put a bang before the expression, that value will update on every keypress inside or any change inside. This is Clojure, or ClojureScript, and you can use this to watch intermediate values. And it's fairly performant, so not just in terms of frame rate, but also things like robustness to indentation, selection, new line spacing. It's also a distributed system, and we can run code on any node that's somewhere out there if we know its ID. So we can just def our RPy here and paste in the ID. And then we can run code on this thing. And the way we do that is we call the node function and say on the RPy, this function should run. And it receives as an argument all of the capabilities of this host. What are they? We can just inspect them. So I query the caps here, and we see some GPIO pins of this Raspberry, some serial port stuff, file system stuff. It's all in here. So let's play with the stuff that's attached to this thing. I can just turn on some LEDs by toggling the Booleans in my code here. Thanks. The editor is also a node, and I can run code on it. In this case, it receives capabilities such as toggling this help modal thing down here, or showing and hiding line numbers, or changing the theme. And remember, anytime I change the color, I change the text. And because there's a bang in front of the expression, the entire function redeploys on every change. And you see, it's quite smooth. Importing stuff from the internet is also a capability, and we can import stuff in any node, including our editor. And you also see that it works with inspecting asynchronous values. JavaScript promises if I run this, it's pending, and then it'll change to fulfilled here. So you can look inside of asynchronous values. It's also an open world system. So while these capabilities are the only way to access the outside world, they are flexible enough to do anything, really. So on this RPy, I'm getting out the function to look at files or directories. And I can just look at the root directory of my Raspberry up here and browse around, like what's interesting, the boot directory, or things like procstat. I can sort of live stream the contents of some file into my editor right here. And then this only works live because of a sort of glitch. We built an infinite loop here. And because this changes the text in the editor, and because there's a bang, it'll redeploy on every change of that file. And because there's no fixed point to be reached, it just goes on forever. But that's OK. If we ever want to stop this, I just put a minus here. OK, now it's the other way around, whatever. But usually you put a minus there and it stops. No idea why it doesn't, but yeah. Because there's the bang here, of course. So let's try turning off the bang, inspecting that, and do procstat again. Whatever. OK. There's also a very lightweight, like I call it declarative process scheduler. It's probably not the right term. But I'll now start that, and this blinks these 3 LEDs. And these are 3 different processes running concurrently. And I'm giving them process IDs. So the keys in here are the IDs, and that's the function that implements them. And if I want to stop a process, I can just comment out this thing. Then you see the red LED stop blinking. Let's stop the green one too now. Only the yellow one is blinking. Let's stop that one as well. And if I comment it back in again, it'll start up the blinking again. So whatever you specify in the code is like this goal to be reached by all of your nodes out there. There's 2 ways to do state in this thing. One is like in Erlang, when you receive the state of the previous iteration as an argument, and you can change it and pass an updated state to the next iteration. So in this case, let's just run this. We blink that LED. We look at the state here. It just Oh, come on. Yeah, I think the Wi-Fi is really like full of stuff here, so it's not super live. But yeah, the other way to do state is to, if you have some expression that you want to like keep the state of, even when you change the code around it, you can mark these expressions as stateful. So in this case, I'm opening the serial port here, and this returns some stateful JavaScript host platform object, and I want to hold on to this even if I do changes in the code around it. I can wrap this in this stateful function and give it some stable ID, and then this value will always be the same. So I can inspect that, and I've got this distance sensor here, which will just stream my value into my editor. Okay. Now, when you're working in a distributed system, it's like your editor is connected to all of the nodes at once, and you usually don't want to look at all of the nodes updating their state or whatever. You want to focus down into one specific instance on your code, say running on that particular node over there. And you can do that with a feature called context. So imagine this is a simple enterprise-y document viewing application, and there's some React components, and what this with context here does is attach some arbitrary piece of metadata to that context of that node that it's running your code. So in this case, we attach the username of the user that's currently logged in, and then anywhere else in our code, we can just use this context function or macro to sort of scope down our views into, say, we want to look at the title of the document that user Dave is looking at. And so Dave's looking at some astronomy stuff here. And let's check what user Sventek is doing. And I probably should not look at that. But you see, you can use that to focus your view down into specific instances or track some users, some request ID across your system. Let's go back to our happy little blinking LEDs. So they're blinking again. The same code as before, and up here is the function that implements it. And I know that this B right here is the value of the pin of any of these LEDs. So we can look at that, and it'll toggle between true and false. And this is scoped to the green LED here, and you should see this. Oh, come on. It's the Wi-Fi. But you should see this like match up with when the green one is on, it should say true and false otherwise. So that's cool, but we would really ideally be able to define very small custom moldable inline visualizations to make this a little more pretty. And we can do that. We can just define a function here which takes that value, and then if it's true, we just show an emoji that looks like a green LED that's turned on, and then here we call that visualization function. And now we get this like sort of view rebuild of the world in our editor, and it should match up. Trust me, it usually does. We can, of course, do a much fancier version of that with like this, which just looks at the context as before of the process ID. You know, these are the PIDs, and now we should see that match up here. All right. Yeah, you can also visualize the history of these values. So you can write a function that looks at the past, I don't know how many, and then you get this. Oh, what is that? That's not supposed to happen. Let me try again. Oh, really? So, okay. Yeah. Now we get this not too terribly useful list of all the state changes of that particular expression in this particular context of the red LED here. But we can improve this a little bit and chuck the timestamp onto this. Come on. So checks the T onto this. And now we have this timestamped log of all the state changes of this particular thing scrolling through our editor. And let's try pausing this now, putting a minus there. Yeah, that worked. So now we can just take out anything that interests us and, you know, paste it here and inspect it some more with our code. Right, you can also do return HTML from your visualization function, mark it with a metadata attribute to tell it to render in a certain way. Now we should have the world's lowest budget, super flaky bar chart in here of some live value over there. Right, running out of time here. So this is the tech stack that I wish I had when I built my tiny SaaS business in the medical sector 9 years ago. It's for hobbyists, solo devs who want something fun and very low ceremony. Is it important that it's written in Lisp? Yes, Clojure specifically, because it puts the data front and center, and you can hold on to it without it changing from you underneath. Obviously inspired by Smalltalk Lisp, especially org mode of Emacs. There's the idea of serializing a round-tripping state, much of the statewide plaintext. Thanks, Jeffrey, for telling me about that. The idea of trace points is from APX. There's IDs in the code, saw that in Captain Proto. There's self-rewriting music, live programming environments, like we saw earlier today. Very lovely stuff. Super custom inline visualizations. There was Eve of like better tools for thought or more humane direct programming. There's darklang. You have live runtime traces and data in your structural-ish editor, and you can play around with production data. There's also this somewhat unknown Clojure notebook style thing, which like the code is your interface to the database, and it's all the same thing, rewrites itself. Yep, it does not have error handling, no code-based management, everything has to be in a single buffer right now. No persistent story, no security as it is implemented here. Also, there's no communication between nodes, which I think electric Clojure would fit perfectly, where you can define the entirety of your distributed system in a single expression and have the compiler infer the network splits and handle the networking for you. Near future, I'm going to turn this into editor extensions so that people are actually going to use this, make it just secure enough to run my own things. Call it via OCAPs, talk to me about that later. Some gnarly open questions. What does it mean to delete stuff, especially if you're done working in a like code-based management style? How do we deal with things that take a long time to run, starting up Docker containers, downloading dependencies, crunching data over hours or days? Anything that's, how do we hold on to things that we can't define ahead of time in the text, like web clients that come and go? Also, what does it mean for a function or different versions of one function to run at the same time all over your system? How should we deal with that? So what have we seen is there's this query macro which rewrites itself in the text to show data of your running system inline. And there's very lightweight distributed declarative deployment thing where you can just say this function should run on that node over there. There's also this context thing to scope down your view into one particular instance or instances, whatever you're interested in. And there's this object capability thing for effects. But really, it's about showing the data and looking inside variables. I mean, how hard can it be? So, thanks.